What's up guys, welcome back to the next video. My name is QDS Dani and you guys watching my channel Koraiwood. Alright, so today we're gonna see what is set builder notation. Please subscribe Koraiwood. As always, our programming videos will continue. At Koraiwood we are committed to bring you the best programming videos. If you like my videos, please subscribe my channel. Click the bell icon to stay updated with my new videos. A set can be described by the certain property P that all its elements have in common. Sometimes we see there is a pipe. So if you guys can see a pipe, there is E, but this E is supposed to be look like this. Keep in mind, but I couldn't find it, so I put it this way inside the computer for such that we're gonna read there is a pipe and there is a E, more looks like the above, and we're gonna read it for such that instead of a colon. So sometimes mathematicians they use this one. This notation is called set builder notation, and shortly we're gonna explain what is set builder notation. It describes how to build a set by telling us precisely the condition elements must meet to gain access. So that's a definition of the set builder notation. It describes how to build a set by telling us precisely the condition element must meet to gain access. So we're going to gain access. In short, we're going to look at this and keep in mind that anything after this, say for example this pipe, our such that is going to be logical statement, and sometimes we're going to see pipe for all x such that our for all x we're going to see for all x such that this way there is a column. You're going to see this way, this also such that then it's going to be the logical. Say for example x, our y, our any other number is greater than, say for example 10. For example, our x is y is even, for example our y is odd or something like that. When you encounter this one, our is more, as I said to you guys before, is more looks like this. It reads as a such that, and after that it's going to be the logical statement. Alright, so we're gonna clear this one. So to describe a set with set builder notation, we write the set of all x, as we said here, the set of all x such that the property of p of x is true. That's how we're going to read this one. The set of all x, the set of all x is this guy here, and we're going to read this one as pipe. The set of all x such that, and it's going to be such that here the property of p of x is true. That's how we're going to read this one, p of x. Sometimes we in mathematics we say of means multiplication. So when you read this one's p of x is true. Sometimes whenever in algebra, whenever something comes in parentheses, it means it's a multiplication. But sometimes we're going to see it otherwise. Is going to call, we said that the set of all x such that the property of p of x is true. So here there is a, there is a equal here, and there is this block here runs from here to here. So in computer science we're going to see this one as a block. Block starts and blocks ends. So a is the set of all n such that, and this guy here, n is non-negative even integer less than 20. That's how we're going to read this one. So a is the set of all n such that, that's a set builder notation, n is a non-negative even integer less than 20. And we can see with a colon as well, as I said to you, they have pipe, and we have this e the other way around, and there is a colon. Now we're going to see with a colon. So here we have a colon here, and we're going to read the set exactly like that. Set of all x, that's set of all x such that x is greater than 5. And as I said, whenever you guys see this one, the colon, and after that it's going to be the logical statement. So the logical statement is a true or false, means is it x greater than 5 or not. So it's a true, and sometimes is x is greater than or less than 10 is a false. Sometimes depends on the condition, and for that condition we say that something is logical. Now we're going to see the set theory notation. Alright, so when we see these braces, our sometimes we call this curly braces as well. Computer science, keep in mind we say this one is a curly braces, and sometimes some people use just the braces to enclose the elements of a set. So as we said previously, 1 2 3 is separated by comma, is the set containing 1 2 3, and that's a set containing, as we can assume this one, or we can think this one of as a container. Our block, as I said to you guys in previous videos, so whatever comes in between here is a container because it contains something. You can see this one as a block. So we've seen this column before, and we say for all, is that the set of all x. That's how we're going to see the set of all x. Then there is a column, we say such that x is greater than 2. Then after that it's going to be the logical statement. And here when you see this one, it means that's an element of, and when you see this one 2, and that's how we're going to interpret this one as a 2, asserts that the 2 is an element of the set 1 2 3. Very easy. And we're going to see this one as there is a cross here, or there is a line here. It says 4, because 4 here is not. That's how we're going to see that this is an element and this is not. When you see there is a line here, it means this is not an element of the set 1 2 3. So in mathematics, anything that there is this line here, say for example for empty set, we're going to see this one. So this line, even in the traffic, it means do not enter. For example, we're gonna so this line here, and this is slash, means that you put it in front of the empty set, or you're going to put it in front of the 0, whatever you guys going to put it, it means it's going to make it null. And we've seen this one before. There is a u, and there is a line underneath the u, and we see this one, there is a, and there is this funny looking u, which points this way. There is a line here, look like a u magnetics or u-turn, whatever. So it asserts that a is a subset of b. So this guy here and this guy, they look very similar, is a subset of b. So a is a subset of b. Every element of a is also an element of b. And this guy looks like that, is a subset, is a proper subset. When there is a line here, is a subset, and when there is no line here, and you guys see this one a, it asserts that the a is a proper subset. So this is a proper subset and is a subset of b. And in the future videos we're gonna go through the subset and a proper subset, because the next video is gonna be about the subsets of b. Every element of a is also an element of b. So this guy here, there is a u, look like you guys going home, and you guys going to an address for a party or something, and then you guys get there and you realize that you guys going wrong way. So you guys turning around and you guys going back to the address which you guys supposed to be in the party. Okay, so that's a u. When you guys making that u-turn, and you guys gonna think that this is a is a proper subset of b. So you guys, by doing a u-turn, you guys doing the making a mark for a proper subset of b. Every element of a is also an element of b, but ab. Alright, so we continue the set theory notation. As I said to you guys, when you guys going into party, and you guys needs to go around the intersections. So when we have turned this way, how about if you go there in the party and you guys losing and you guys turning this way? It's the same as intersection. You guys going, there is a lights here, whichever way you guys going. If you coming this way, you look at these two lights. If you're coming this way, you look at these two lights. So it depends which direction you guys coming. So here there is u or n, you can this one read this one intersection. So this is an intersection. Think this one is intersection because when you guys going to the party and when you guys crossing this intersection, it means you guys doing this way, or not this way, you guys going this way. So this is intersection of A and B, and keep in mind intersection is like that. It's like cross in everyday life. We're going to go here, but sometime you see this one, there is two not a very round circles, and this is intersection. This place is intersection where the two line meets. So this line here and this line here meets, and that's exactly applies here. There is a two round circles, and when they meet, it means there is have an intersection of A and B. Of A and B, the set containing all elements which are elements of both A and B. So that's exactly the true here. So there's a vertical line here, a horizontal line here, and there's here because the both elements are meeting here. So when you see this U, it means that's union. It's not a union of say for example building and construction, or the union of the computer programmers. You guys are going to see the police union or any other union, but this union is when you read this one, A union B is a union of A and B, is a set containing all elements which are elements of A and B or both. We can see this one in everyday life. We have seen the police union, our workers union, our this union. So when we mean union, it means that there is two people here, person A and person B comes together and they meet, or they come together in a house or something. So they they make a union. So A union B is the union of A and B, is a set containing all elements which are elements of A and B or both. Now you guys see this one, maybe you see this one every day. That's look like multiplication, and A multiply B is this Cartesian product, and we're gonna read this one as a product of A and B. So that's A and B, the product of A and B, the set of all ordered pairs A B with A in A and B in B. And you guys see this one, there is a backward slash is the difference between A and B. So you see in this one, there is a there is a backward slash is the set difference between A and B, the set containing all elements of A which are not elements of B. So now, as I said, this backward slash is a difference between A and B. Think this one as inside the movies, there is a hero and there is a villain where they don't get along, so they have a difference of idea, difference of interest, difference of whatever. So you guys gonna put a hero and a villain here, and you guys gonna put a backward slash is the set difference between A and B, the set containing all elements of A which are not elements of B. So these guys have whatever attributes or property this one have here, this one doesn't have. So they have a difference because whatever characteristics of the hero inside the movie it has, the villain doesn't have that sort of characteristic because it has a evil intentions, evil whatever, and this guy here have good intentions to build and to bring a peace and for well-being of people. And this guy here, which is a villain, think of this as a villain. So this one wants to destroy, and this one is just selfish. He wants his own self-interest above everyone else. So this one we're going to read mathematically is the set difference between A and B, the set containing of all elements of A which are not elements of B. So the A, we have there is a line on top, look like there is an umbrella, or you guys can think of a hat, or the guys can think of a roof, anything, whatever the A has, the complement of A. So we read this one as the complement of A. And what is the complement of A is the set of everything which is not an element of A. And you guys are going to see there is a which looks like it's standing in the middle of the door, or in the middle of two columns, or you guys gonna think of there is a movie hero which are holding the two containers. It doesn't want, because in some Superman or something you see that the hero is holding both ways, doesn't want this train to collide to the wall, our car to the wall, or holding something. And you're going to see this one is the cardinality or the size. So when you see the cardinality, it means that's the size of A, is the number of elements in A. Alright, so we continue our discussion for the set theory notation. Another way to compare the sets is there by their size, and keep in mind what I said in the size is this guy here. As I said, there is a hero inside the movie which is we call Superman. Our Marvel movies which are holding, keep this one as a hand, which are containing both sides, and we see this one the size. The size of a set is the set of the size of a set is called sets cardinality. So that's what we call this one as here. The size of a set is the set's cardinality. That's what we're going to see this one. We can write this guy here, the cardinality of A is equal to 10 and B is equal to 5. If A is finite set, we define cardinality of A, we write is A to be the number of elements of A. So we're going to see that there is the size of this guy here, A and B is 2. And we're going to give you guys some example, and you're going to see this one, what is the cardinality of this A, because this A has got 1 2 3 3 elements. So the set of A has 3 elements, and we're going to see the cardinality of A, which is the size of A is 3. And here we're going to see another one, B, which contains 3 5 5, and we're going to see this one, as we said in the previous video, that the order is not very important, and we're going to see that the cardinality of this one is 2, of B is 2, because 3, and we're going to see this 5 and 5 is the same. So when we come to the size, it means this one have 2 elements here. And now we're going to see this one, the cardinality of C, and we're going to see that one. So 1 2 3 2 1. Now you guys going to tell me this one, that's 1 2 is unique. 1 2 3 is unique. What about 2, which have the same common, and we count it as 1, and there is 1 here when we count it as 1, and that's one which is going to be 3. In cardinality, keep in mind we do not count repeats in cardinality. So whenever you guys see the repeats, we do not count. For example, if you see J in a zoo, for example, it has a zebra, it has a lion, it has a, say for example, tiger, then it has a zebra again, then it has a lion, and that's braces here. So we have a zebra, we have a lion one, we have a tiger, which are unique, because we're going to see in cardinality, we're going to see the uniqueness. We do not count the repeats. Whatever the repeat here, we do not count, and that's exactly true in computer science as well. So when you guys go in computer science sets, we do not count this one. The computer just ignores the repeats here. In Python or in C++, any other language, when we see this one in algorithms, we do not count whatever. When computer encountered the zebra and lion and tiger, and keep in mind zebra and lion again, then the computer just ignores this one. So that's exactly true in mathematics as well, because mathematics is the roots of computer science. With all algorithms, everything is built on mathematics, so we follow the same rule. And in cardinality, we do not count the repeats. So this zebra and line, we do not count. So here we're going to see the cardinality of say J, which is the size of J, and we put it as 3. So I'm going to put it as 3 here. So the cardinality of J is 3. So we're going to say 1 2 and 3, and we won't encounter this one. This one has a repeat of the zebra, this is the repeat of the line, so we do not count. So we say that the cardinality of J is 3. Alright guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.